Hi folks, Joseph Kursky here with you to talk about enriching instruction with 3D mapping. Enriching instruction with 3D mapping. Now, one of the most commonly used themes in GIS instruction over the past 20 years is the mapping and analysis of earthquake data. There are many good reasons why many of us teach with earthquake data, including that one can easily obtain real-time feeds from the U.S. Geological Survey, in addition to historical earthquake data, the fact that spatial patterns as well as those of magnitude and depth are fascinating to examine, and also that the teaching of natural hazards touches on so many other pertinent themes and subject areas, including settlement, proximity to oceans, land use, slope, history, earth science, geography, and mathematics, and that GIS and spatial thinking skills can be fostered. So all of those reasons are good reasons to teach with earthquake data. Now, core to what many of us in the GIS education community hold dear is the message that just because a tool exists, that alone is no reason to use it. Very true. And that message applies to the 3D scene viewer. Yes, you and your students could make 3D maps of many of the variables that you already map and the themes that you teach, whether it is natural hazards, earthquakes, as I'm explaining here, or tornadoes, hurricanes, wildfires, hailstorms, and others, population change with population characteristics or changes in neighborhoods, counties, states, or countries shown as extruded polygons. Field data, as in the 3D scenes that I made recently of student weather balloon launches or paragliding, or many other types of data. But only do it if it enhances your instruction and better enables you to meet your teaching goals, whether those goals are content, theory, or skills. In the case of earthquake analysis, mapping the data in 3D adds value, folks. It adds value, and therefore I do it. I do similar work from time to time in examining population change, with extruding polygons showing growth or decline, and in many other activities. I don't use 3D in every lesson, certainly, but when I have done so in professional development, sessions with faculty, or teaching university or primary or secondary school students, I've noted a greatly increased level of engagement in the content, an increased number of relevant questions being asked, and focused investigations. Now, our world is a 3D world, right? And there's no reason to confine yourself to 2D maps, even if they're in digital form, when these 3D tools are at your fingertips and viewable on any device. Below is a static view of my 3D scene for 30 days of earthquakes. Or you can interact with it here. Now, how did I create this? First, in ArcGIS Online, in my content, I added the USGS real-time earthquake feed, CSV, comma separated value file, showing all earthquakes over the past 30 days with a magnitude of 2.5 and above. I created a feature service from this CSV file. I then started a new 3D scene and added my new feature service to it. I then changed the style to map the variable mag for magnitude, selected the thin cylinder, adjusted the size to be a range in meters from 75,000 to 600,000 on the ground, 600 kilometers high for the most severe earthquakes. In other words, I tweaked it so it would be just right and effective, and used absolute height for the elevation mode. And then I turned on the pop-ups, legend, and labels using mag as the label field. So go ahead and use my interactive 3D scene for earthquakes in your own instruction. You don't even have to log in to do some powerful things, such as turning on the shadow and changing the date and time for a quick lesson about seasonal change, or to navigate to specific areas around the world to analyze the number and the magnitudes of earthquakes. Be sure to check out those earthquakes shown on the horizon in the image here. What is the name of that island chain to the northwest, by the way, and why do so many earthquakes occur there? If you do log in, you have even more power at your fingertips. For example, you can add data to the scene, such as plate boundaries, volcanoes, fault lines, or world cities. This will allow you to extend the inquiry to investigate the proximity of earthquakes to different types of plate boundaries, subduction zones versus mid-ocean ridges, for example, to specific types of volcanoes, to fault lines, to surficial geology, and to major population centers. Which cities are at most risk? Then you can save the 3D scene with your own added layers to your own ArcGIS Online account and reuse it in the future. To dig still deeper into the world of 3D, try Esri's City Engine. So I just pose this to you at the end here. How are you using 3D scenes in your own instruction? Thanks.